so today we will talk object-oriented programming in R. Okay. Blah, 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 blah. All right, so basically, in R, we have base types. Those are all the things that we've covered so far. Base types are the atomic vectors, your lists, your functions, a few other things are thrown in there. But those are pretty much your base types that are most important. Vectors, lists, functions, some other stuff, okay? On top of that, we have objects, object-oriented stuff. And we have basically, here, well, let me go on. And so we've got a few different object-oriented systems in R, okay? Today we're going to cover S3. S3 is the basic system, and it's most commonly used in R. It uses generic function object-oriented programming, okay? Which is different from most other languages. So if you've done programming in other languages, you're going to look at generic function object-oriented stuff, and it's going to feel weird, right? If you haven't done any object-oriented programming in other languages, then you'll just say, huh, okay, that's object-oriented stuff. And then when you look at another language, you'll say, well, that feels weird or something. But most other languages don't do generic function. They use message passing object-oriented stuff, but whatever. This is what we have, and we'll talk about it today, okay? There's S4, which is another object-oriented system in R. It's more formal, more rigid, but it's still another generic function object-oriented system. And it's very similar to S3, but again, just more formal, okay? And then finally, we have reference class. Reference classes are more like the message passing object-oriented stuff. So in that case, the methods belong to the objects themselves. And we'll also look at this reference class later this week. But today we'll focus on S3, okay? Okay, and then this is not object-oriented stuff, but we have base types. And the base types, these are the types that you are already familiar with. Those are the vectors and the lists and the functions. And those are base types. Those are actually implemented in R as C structures. So underneath R, it actually runs C and Fortran to do all of the heavy lifting in the code. But R kind of makes it so we don't have to worry about figuring out where to store things in memory and stuff like that, and it handles all of that for us. But underneath R, there's some C-level stuff, okay? And so anyway, I don't have a slide for this, but let me just talk about why we're bothering with object-oriented stuff to begin with. So, if you've done stuff with R, you've probably used the summary function, right? Okay. So if you give it a numeric vector and you ask summary on the numeric vector, what does R output? What's that? Some summary statistics, right? Pretty much a 5-number summary. You get like the minimum, the max, the first and third quartiles, the median, plus also the mean. It doesn't do the standard deviation though, right? So you get like a 5-number summary, and you can give it a numeric vector, and that's what it does. If you give it a data frame with a bunch of numeric columns, what does the summary do? It outputs that information in a different format, but it does it for each variable, right? If you create a linear model object, let's say you do linear regression, right? And you store that output as, model, or your fitted model or something like that. You can also call the same function summary on that, and what will that output? That outputs information, summary information about the linear model, not a 5-number summary. Right? So how is the same function able to do all of these different things? Okay. Well, that's what object-oriented programming allows us to do. It allows us to just, all we have to do is remember the function summary, all right? And we don't have to remember that there's a summary function specific for linear model objects and a separate summary function specific for numeric vectors and a separate summary function that's specific for data frames, okay? It's just a summary function. We call this a generic function, and then when you give it a vector or you give it a data frame or you give it a linear model or something else, R will figure out, oh, I'm going to run code for this type of object, okay? And so that's what object-oriented stuff allows us to do. We don't have to learn every single function that exists in R. We just have to know kind of like the important ones, like print and summary. And lucky for us, there are specific versions of those functions that will run for the different types of objects that exist. Okay, so let's talk about this. Okay, there's a library called Prior that Hadley Wickham created, and it's useful for figuring out object-oriented stuff. But to be honest, outside of this, like today's lecture and maybe Wednesday's lecture, we'll probably never touch this package again, right? We don't often do a whole lot of investigative work on figuring out object-oriented properties, but it's useful for today. Okay, so we've got the base types. Underlying every R object is a C structure that describes how the object is stored in memory, okay? And this is the base type, and you figure out the base type using type of, right? So type of, you give it a vector and it will say, oh, it's integer type, or it's character type, or it's a list, or something like that, right? And then there's other ones such as names and calls and promises, but we won't worry about that. Unfortunately, as far as the base types go, they're not named consistently. So we do have things like is.integer, and the type of is integer, and that makes sense, okay? But if we ask type of on a function, which is a base type, it will say closure, but we don't say is.closure, we say is.function, right? Which feels a little funny. Some of the functions are known as primitives, okay? But if you ask type of on the function sum, it's going to say built-in, right? So the function sum, there's no actual R code there. It's implemented in C. So when you give it a vector, it can add those numbers up really quickly without having to mess with R code. Which, well, we love R code. It's not the most, it's not the fastest code in the world, okay? Don't worry about mode and storage mode, but we'll use type of, okay? And we can see if an object is a base type by using the command is.object, and if it's an object, is.object, it will return false for base types. It will return true if it's an S3 or S4 or something like that. Okay, so let's talk about the S3 object-oriented system. That's what we'll spend the rest of today covering. All right, it's the simplest object-oriented system that R has, and it's kind of ad hoc in that we kind of create things on the fly, and it works. You don't have to formally define and declare things early on. You just say, hey, I want to make an object of this class, and R goes, all right. And it works, okay? You just don't have a whole bunch of safety checks per se, but as long as you don't do silly things, you'll be fine, right? We don't have a function. There's not a base function to see if something's an S3 object. You can do is it an object, and that should return true, but then that is object will return true for both S3 and S4 object types. So you have to say, is it not S4? And that's how you can tell if it's something S3. Okay. If you load up the library prior, then you can use the function OType, and OType will say this is an S3 object. Okay. But the function OType is pretty much this check right here. Okay. So examples of S3 objects are data frames and factors. So we've already encountered those, but those are S3 objects. Let me pull this up in our studio here and clear this all out. So here I'm going to create a data frame. Okay, so here's the data frame df. It's just got the numbers over here and the letters over here, right? And if we say, if I ask type of on the data frame, what is it going to say? How is the data frame stored in R? We don't remember? We do? It's a list, right? Data frames are stored as lists. They're implemented in R as lists. Except that each list has to be of the same length. But if I ask what's the class on the data frame, this will say data.frame, okay? So the data frame is a class of class data frame, but the type of is a list. And if I use the function OType from package prior, you've got to load up library prior or install that if you don't have it. And it's going to say it's an S3 data type, S3 object type. Okay. If I subset the data frame to just X and I have a numeric vector, what will this be? What is the type of on this? Type of df $x. What is this? So I created it doing X is 1:10. So that's going to give me integer type, okay, and this is a base type, and so if I say OType on df $x, it's going to say base type. All right, what about df $y? What is this? It's a factor, right? Because the default behavior of data frame is to take character data and turn them into factors. If I ask type of on df $y, how is a factor stored in R? Yeah, I know I put this in your homework, right? It's an integer type, okay? And we could ask, as.integer df $y, right? And it prints out as an integer, okay? But and if I ask what is the class of df $y, what is the class here? It's a factor, right? And then so we ask what's the OType on this, and it's an S3 object type. Okay, so data frames and factors are examples of S3 objects in that they are stored in memory as base types, right? They're stored as lists, they're stored as an integer vector, but they don't behave like a regular list, or they don't behave like a regular integer vector in that they do their own thing. And so, and that's implemented by taking that base type, the integer, let's say for the factor, we take that base type of the integer vector, and then we add some extra code and stuff so it behaves the way it does as a factor. Okay, and that's all we do with the data frame 2. We implement it as a list, but then it behaves differently. All right, so how does this work? Well, in R and the S3 object-oriented system, we have what's called a generic function, right? And so I mentioned a generic function such as summary, right? And when I say generic function, it just means you can use that same call. You can just type in summary parentheses, and you give it a numeric vector, you give it a data frame, you give it a linear model object, and that generic function is able to handle all of those different types. Okay? And it's not just R has built some super fancy thing. What it says, the way it's implemented, is it uses something called use method, right? So mean is an example of another generic function. So I could say, you know, what is mean? And normally you do mean parentheses and you give it the vector that you want to find the mean of. But if you just type the name of the function, it will tell you the underlying code, right? And so if we ask what's the underlying code for summary without the parentheses, what is it going to say? It's going to look exactly like this because it's a generic function, except it will say use method for summary. Okay? So summary is a function where it takes in the object and it uses the method summary. So this just says summary is a generic function, and a generic function just means when you want to run the function, you just type in the word summary, and you don't have to specify which specific version of the function you want. R will do that part for you. It will figure out, you have given me an atomic vector, therefore I'm going to use this method of summary. You have given me a data frame, therefore I will use this method for summary. You have given me a linear model object, therefore I will use this method of summary. And that's what use method is. It says, here's the function, I'm getting this different type of object, I'm going to figure out which code I need to execute. If we run the command ftype, function type, it will say it's a S3 function and it's a generic function, meaning that this is a function that will look up other specific functions called methods. Okay? And that's called method dispatch. You call the function, you just say, I want the mean of something, and R will figure out which method to execute. Okay? We have, there's something called internal generics, and these are kind of generic functions that are implemented in C, so we don't get to see the underlying code. But, you know, the other stuff, the generic functions, the way they're written is you have the name of the generic dot the class. So we have, when you call the mean function and you give the mean function an object of class date, what it's going to do is it's going to look up the code that's for mean.date. Basically, it means run the mean function for objects of class date. If you give the mean function a different type of object, it will look up mean dot, something else. So here, we have a summary method specific for linear models, and that's what it's going to run. So if you ask the summary function on a linear model object, it's going to look up which function it needs to run. Summary.lm. This is the code that it runs when you call the summary function on a linear model object. If you, there's a default code. Okay, this is the code that it runs for in default and things like that. Okay, so print, there's a whole bunch of methods associated with print. Okay, and we've got a method for when we ask it to print a factor, it's going to look like this, right? That's why when you ask R to print out the factor, it includes the levels rather than just printing them out as integers. Okay, because the methods are named using the dot. Most style guides will say don't use dot in your variable names because that can confuse things. So, we have the function t.test. This was before the style guides were implemented. And so t.test, the way it's written, looks kind of like a S3 method, which will be, in this case, be the t function implemented for objects of class test. but that's not the case. T.test runs a t-test or a Welch test on your data. And so, these are kind of exceptions to the thing. Print.data.frame could be, the print method for objects of class data frame, data.frame, which is what it is. But it could also appear to be, the print.data method for objects of class frame. So it's so using a dot in the names is not recommended, but that's what happens. Okay. So there is a function called t.dataFrame, and this will implement the transpose method for objects of class data frame. Whereas the t.test, this is a function that R can implement here as a generic function there. We can see all of the methods associated with a function by just saying methods, and we give it the name of the function. So in this case, so I can say methods associated with summary. Okay, and we see there's 33 different versions of the function summary. Okay, so we don't have to have all of these memorized. We can just call summary, and R will figure out which version is appropriate to use for the object that you gave it. Okay, and then when we ask print, there's actually a whole bunch of print methods. Okay, there's 205 of them, and we don't have to have all of these memorized. When you ask print some object, R figures out which method is appropriate and prints it accordingly. That's why when you call print on a data frame, when I say print on df, it knows to print it this way. Even though the type of the data frame is a list, it's not printing as a list. Oops. Okay, if we print it as a list, it would look like this, right? But it's not printing it as a list. It knows that it's a data frame, so it outputs to the screen in the appropriate way. Wrong button. Okay, so we can see the methods associated with a function. You can also see all of the functions or the methods associated with an object of a certain class. So this is a class time series, and you can find all the functions associated with that. I could ask R, what are the methods associated with class equal to linear model, LM, right? And so we have all of these things. We have our own summary method, we have our own print method, we have our own kind of, these other functions, ANOVA method and things like that, right? Linear models have their own plot method. So I don't know, if you created a linear model in R and you say print and you put in that fitted model, it prints out what, five different figures, one of them being like the residual plot and the QQ plot on the thing. Like that's not normal print plot behavior, right? Normally on plot it'll create like a scatter plot or something. That's not normal plot behavior, and that's because there is specific code that is specific when you call plot on an object of class linear model. That's what's going on. Okay. All right, so let's talk about what if we want to make our own classes and our own methods. Okay. Well, we can define our own class using the function structure. We say, I'm going to create an object foo. It's an empty list, and all we do is we say the class of this thing is class foo. Okay. Another way is we can create the object. We just create the empty list here, and then we just change the class of this thing to the thing we want. So in this case, we're going to change the class of this to class foo. So that's one way to just create it. And then R just says, okay, I've never heard of this class before, but sure, let's go with it. And now you have objects of class foo. So this is kind of what we mean by the ad hoc system of the S3 object-oriented system. R just says, class foo, that's interesting, and it goes. Okay. Most of the time, S3 objects are built on top of lists or atomic vectors with attributes like factors and stuff. But you could turn whatever it is into an object. Okay, there's a function called inherits that shows you how to see if the object inherits kind of the methods associated with another class. So, for example, we have the class linear model, and we saw a bunch of functions that were specific to class linear model. Okay? We also have the generalized linear model, GLM, right? That's another thing, and you can create like logistic regression models and stuff like that. And when you run GLM, it's going to create an object of class GLM. Okay? Because GLM is kind of like a linear model, but it's a little bit different, we say that GLM can inherit from linear model, right? And so that means the way it works is that when you call the function, call a generic function on the object that's a GLM object, R will first look for functions specific for GLM. But then if it doesn't find objects specific for GLM, then it kind of generalizes it and looks for objects or functions specific for LM. And if it doesn't find anything there, then it kind of generalizes that further, right? So, so we would say GLM inherits from LM, linear model. Generalized linear models kind of inherit from that. And so that's what we have here, okay? So you can say the class of an object is a vector. And so the class of the object GLM is the vector GLM and then LM, meaning that this tells R, first look for methods or functions specific for type GLM, and if you can't find it specific for this, then look for this type, okay? And then if you can't find it for that, then just use the default. So usually you go from the most specific to the least specific. Okay, class names are usually lowercase. You should avoid the dot and that. A lot of times when you define a new class, you probably want to create a function called a constructor, which is a way to kind of create objects of that class. This isn't optional. You don't have to do this, but if you want your class to be used regularly, it's a good idea. So kind of like if you wanted to create factors out of a vector, you would just do factor and then you'd put in that vector, right? And when you do that, R creates a factor. And that's what we call a constructor. So here I'm going to create a function called foo, and whatever I put into the function foo will be an object of class foo. And so this is just a very, very simple function in that it just takes the input x and it throws it into a list and says the class is foo, and it just does one check that says x has to be numeric. But a lot of times the function is a little bit more complex than that. But this is just something that often happens. So so for example, we have the function lm, right? This creates a linear model. The function lm itself is a constructor, so that when we call this function and it creates all of this stuff, it finally outputs a list z, or a list, which is our linear model that we get. And so the function lm creates objects of type lm, and we have all of those functions there. Okay, so here's the example. So here I'm creating a model using the function lm. When I create the function lm, I get the object model, and then if I ask what's the class of this thing, it's going to say it's the class lm. If I call print on the model itself, it runs the code specific for linear model objects. It runs print.lm, which is how should I display the output of this linear model. If let me look this up here. Okay, so if I look at model itself and I do type of for model, it's actually a list, right? So if I do as.list model and then we print this, okay, no, that didn't work. And let me just do print.default. Okay, so here it's printing kind of at the way the list looks, and this is not how we're accustomed to seeing the linear model print. And we probably wouldn't want R to continue to print out the list this way, right? We wouldn't want the output this way, and so instead it calls the print.lm of the model, and couldn't find the function print.lm. Okay, but so yeah, you call print on it, and it outputs the thing here. So we ask class.model, let's type lm. Okay. We can mess around with this, right? The class of model is lm, but if I wanted to, this is a bad idea, but I could say we're going to make it a data frame. Okay, so now the class of model is a data frame, and then so if I say print the model, now it doesn't work. The stuff is still there, so I can still look up the coefficients in the model, and that information is still there, but R is trying to display the information in this object as if it were a data frame, and that doesn't work anymore. So this is a bad idea to try to change the class of your object, but you can do it. Okay, so and that's because the S3 model is just very loose and ad hoc, and it just goes with the flow. But so just don't do silly things like that. Okay. All right. What if we want to create our own generic functions and methods? Okay. So here, if we want to create our own generic function, all we have to do is just say, when we define the function, we use the command use method. Use method tells R this is now a generic function. Okay. Generic function, again, the idea of the generic function is that you have one function, in this case f, and you use the same function on objects of different classes, and then R will figure out which specific version to call. So do I call the method for objects of class A? Do I call the method for objects of class B? That's what we have, okay? So we define a generic function with f. We define the generic function f using the function use method here, okay? So this defines a generic function. And now we define a method. This is the version of f that will execute for objects of class A, all right? And so as far as this function goes, it does nothing impressive. It just outputs the character string class A, okay? But this is to illustrate, this is the version of f specific for objects of class A. So now I can define a new object. I'll call this A, and this is class A, right? So if we say, what is the class of object A? It's going to say class A. And therefore, when I execute f on this object A, it runs this function, this version, and it says class A. Okay, so here. So right now, so you'll see this. F is a function. I'm going to create a version of f called f.a, and this is the function that will run for objects of class A, okay? And all it does is it outputs this, right? So notice I didn't have to call f.a on A. I could do that, but I didn't have to. I just called f on the object, and R figured out that it needs to run the code for f.a, right? The mean is a generic function, right? Because if we look up what's the code behind f, The code behind f is use method. What's the code behind mean? It's also use method, right? So these are both generic functions, and so I could create my own version of the mean function, okay? This is mean.a. This is going to be the version of the mean code that gets executed when I run it on this. So before I do that, if I say run mean on a, it's going to say it can't do this because it's not a numeric or a logical vector, right? But I'm going to say, you know what, R? I don't like what you told me. I'm going to make my own version of mean, okay? It's called mean.a, and this function is going to tell me what I want to hear, and it's going to say the letter A, right? And so now, if I run that same code, mean on A, R will say, all right, you win. I have found the version of the mean function specific for objects of class A, and I have output the character A for you. Okay, that's all it's doing. Okay. Here is let's say I create an object B. Okay, so B will just be the value 0, but we're going to say class of B is type B. Okay, so B is this, and if I say what's the class on B, it's B. So if I call the function f on B, what is it going to do? Okay, it's going to complain. It's going to say, you gave me an object of class B, and I don't have a function defined for that. I don't have an f.b, okay? So what we have to do is we can either create a function called f.b, or we can create a default. We can do f.default, and this will say unknown class. F.default will run for everything where the specific method is not defined. Okay, so when I did f on B, it said, I don't know what to do. If I call this now that I defined a default function, then it says, all right, unknown class here. Okay, so f on A will return class A, f on B returns this, okay? Let's change class of B. Class of B, we're going to call, we're going to give it a vector, B and then A. All right, so this means, this tells R, first look up, see if you find a method specific for class B. And if you don't, then see if you can find a method specific for class A. So if I run f on this, what will it output? Will it return unknown class or class A or an error? No attempts? No guesses? All right. It returns class A, right? Because it said, do I have something specific for objects of class B? Do I have an f.b? No, I don't. So I said, okay, I failed you here. Let's see if I find something here. Ah, yes, I found f.a. I'm going to run the code for f.a, which will output class A, and so it works. Okay. All right, let's we'll create C. This will just be an empty thing, okay, and then we're going to say the class on C is C. Okay, so class C. So now if I call f on C, what will it do? I have two things defined. I've got f.a and I've got f.default. So what's it going to output? It will output unknown class, right? If I change the class of C to C and then followed by B, okay? So that's this, and so the class of C is this, and if I run f on C, what will this output? It's still unknown class, right? Because it's looking for an f.c or an f.b, and we don't have anything. If I can define something, I can say f.b is a function, and what it's going to say is this is class This is the function for class B, okay? So this is now a new function, and so now I can call f on object A, and it runs the method for that. I call the object on B, and it runs that, and I call, if I look at the class of C, this is what we have. So I'll call f on C, and what will this be? It'll say this is the, oh, I spelled that wrong, function for class B, okay? Does that kind of make sense? What R is doing? It's looking for the method specific for the thing here. Whoops, clicked the wrong thing. All right. If we wanted to, yeah. So it says, as you can see, there's no check to make sure that the method returns actual, the class that's compatible with the generic. Okay, it's just you just kind of define these methods as you want to go, all right? So we did all of this stuff, and this is group generics, don't worry about that. Okay. The methods themselves are just our functions, so you can call them directly, okay? So if I wanted to, I could call f.a on B, right? So normally f of B will return this thing, but we can force it to run the wrong method, and it will say class A, right? And we can run it on this, and it runs, okay? You should just let R handle this. You should let R figure out which is the correct method just by calling the generic function without the dot. But if you wanted to call a specific method, you could. And again, this is dangerous. It's like changing the class of the object, but here you're kind of forcing the wrong method to run, and so this is not a recommended thing to do, but it is possible. They are just functions implemented in R, and so if you wanted to call the wrong method for a different object type, you could do that, and R will do its best to execute. Okay, so this is object-oriented programming. This is the S3 stuff. The specific methods belong to the functions. The generic function says, oh, I've received an object of this type. I'm going to look up which method to run, and it runs the appropriate method that way. Okay, we'll end here for today, and we'll see you guys on Wednesday.